Hello everyone, and welcome to this video on approximate integration. So what we're going to do is we're going to do a left rectangle approximation method, a right rectangle approximation method, and a trapezoid approximation method. Okay, so basically we have a table here with x and y values given right here. Okay. And what we are interested in is we are interested in estimating, okay, just give me a second here. We want to estimate the integral, and in this case we're going to go from -4 to 20. We're going to do the entire thing here. Integral from -4 to 20 of the function that we're dealing with here, okay? So that's the idea, okay? We use these rectangle approximation methods and trapezoid approximation method for estimating definite integrals, okay? And the thing about this particular example is if you look at the width, for example, the width from -4 to -2, that's going to be 2. -2 to 0, that's going to be 2 as well. 0 to 1, that's going to be 1. So in other words, the width here is not the same everywhere. 1 to 4, that's a width of 3. 4 to 9, that's a width of 5. So again, the point is, the width is not the same everywhere. Okay, but we can still do the approximation. Okay, so let's sort of jump in. Let's talk about the differences between left and right rectangle. Okay, so here we go. So let's remember the area is approximately, and what are we doing? We are adding. That sigma looks horrible. We are adding from I equals 1 to n, and this time we're actually going to specify how many rectangles we're going to have, okay? And what we're going to do is we're going to take the x value and we're going to multiply that by the corresponding width, okay? Now, the left rectangle starts at the leftmost point, okay? So LRAM, left rectangle approximation method, okay? It's going to start at, let me think here. Oh boy. Basically, it's going to start at the leftmost, okay? I'm going to call it x1 and ends not all the way to the right, okay? It ends one before the rightmost, okay? So it ends at x sub n minus 1, okay? Now, on the other hand, for the right rectangle approximation method, we're going to start not the leftmost, we're going to start at the one right after that. So we're going to start at x sub 2, and we're going to end at x sub n, okay? These are the only differences between the two, okay? And finally, the trapezoid approximation method is literally, by definition, it is the left rectangle plus the right rectangle divided by 2. Okay, and we're going to explain, more and more of this as we go. But for now, let's stick to the example. Let's do left RAM and right RAM first. Okay, so like I was saying, we are going to plug it into this formula right here. Except for left rectangle, we're going to start at x sub 1. So let's do it. Okay, so I'm just going to, I guess I'll do this. Yeah. All right, so here we go. All right, left rectangle approximation method. So the area that we're trying to find is going to be approximately, And here we go. We're going to start at the leftmost, okay? So it's going to be 0 multiplied by the width. Now to do the width, we're going to start here, and we're gonna just basically subtract these and make it positive. So -4 to -2, that's a width of 2. Okay, now plus. Okay, that's our first rectangle. All right. Now for the next one, we're just going to march over by 1. Okay, so in other words, this is going to be the y value for the next one, and the width is going to be found by looking at these. Okay. So -2 to 0, that's going to be a width of 2. Okay. Very, very good. Next, okay, plus. We're just going to keep doing this, all right? The y value there is going to be 10. And now to calculate the width, 0 to 1. 0 to 1, that's going to be just 1. Plus. The y value is 15. And the width is going to be 1 to 4, so that's going to be 3. Plus, y value here is 11, and the width, 4 to 9, that width is going to be 5. Plus, y value is 9, and for the width, we're going to be going from 9 to 10, it's a width of 1. Plus, and here's the last one for the left rectangle. So like I was saying, right? The left rectangle ends here. The right rectangle is going to start here, end here. Okay, so once again, left rectangle starts here, ends here. Right rectangle starts here, ends here. Okay, so anyway, y value is going to be 7, and then to calculate the width, 10 to 20. That's going to be 10. Whew, there we go. Okay, so now we can just kind of simplify. 0 times 2 is going to be 0, plus 10, plus 10, plus 45, plus 55, plus 9, plus 70. Okay, awesome. So let's see, 55 plus 45, what's that going to be? 105? No. No, not 105. 100. 100. 100 plus 70 plus, 199. Okay, that's for the left rectangle. All right, now let's do the right rectangle. And again, we're going to use the y value starting from here and ending here. But a lot of the stuff in the middle is actually going to be the same. Okay, and I got this space problem here. I guess what we'll do, I guess we don't really need this stuff anymore, do we? So let me just, we know what's going on, so let me just erase a little bit of stuff here. I'm going to erase, because this is what we're doing. We know what we're doing already. And you know what? I'm thinking this is probably enough space. So here we go. Let me change my color. Right rectangle approximation method. Here we go. Okay. So y values, we're going to start off not the leftmost, the one right next to it. Okay. So we're going to go 5, and now here for the width, we're going to go this way. Okay. So again, it's -2 to -4. The width there is going to be 2. Okay. Width can never be negative. Width can never be negative. Okay. Next, we're going to use this y value. And then we're going to go 0 to -2. That's a distance of 2. Plus, here's this y value. And then the distance between 0 to 1 is going to be 1. Plus 11. And then the distance from 1 to 4 is 3. and then we get plus 9, and yeah, there's 9, and then the distance from 4 to 9 is going to be 5, plus, and now we're here, 7, and then 10 to 9, that's going to be a 1. And then finally, we're going to end at the last y value, so it's going to be 0. And then the width from 10 to 20, that's going to be 10. All right, so now we wind up with 10 plus 20 plus 15 plus 33 plus 45 plus 7 plus 0. Okay. All right, so if we add these bad boys together, 45 plus 33, that's going to be 78, 98, 108, let's see, 115, and then this one here, 130? I think it's 130. Let me add it up one more time. 45 plus 33, that's going to be 78, 88, 93, 113, 123, there we go, 130. Okay, boom, there we go. And also, yeah, this kind of ties back to another video I was talking about where I actually plotted these functions here. Clearly, 199 is bigger than 130. And if we look here, 0, 5, 10, 15, 11, 9, 7, 0. Okay, so first we're increasing, and then we start to decrease. Okay, and if you remember, for an increasing function, for a function that's increasing the whole way, the left rectangle will be an underestimate. Okay, so that means that this function is actually decreasing a little bit more overall, because we got 130 here for the right and 199 for the left. Okay, awesome. Okay, now the trapezoid. Trapezoid. If you're sure, that you got everything right, then you can literally, just plug it in here to get the trapezoid approximation method. So 130 plus 199, all of that divided by 2. What's that going to be? Well, let's see. It's going to be 329 divided by 2. Let me do that one more time. 200 plus 130 is 330. Minus 1 is 329 divided by 2. All right. Now, the last thing I want to do for this video is I want to do the trapezoid. I want to basically derive the trapezoid formula and then use the trapezoid formula to see if we get the same thing that we got here. Okay. All right, so, boy, I'm just kind of out of space. All right, let's come over here. So trapezoid approximation method, like I said, it literally is the left rectangle plus the right rectangle divided by 2. Okay, and we are going to keep this just like it is, and we're going to expand now. So let's remember the left rectangle starts with the first x value, but does not include the last one. Okay, so in other words, this. Let me do the color thing. I'm going to write down the exact same thing that I just had, but I'm going to put it in green. Okay, so this is going to be f of x1 delta x1. okay, plus. Now I'm going to write down the stuff that they have in common. All right, so we're still thinking about left rectangle. Left rectangle is going to contain the second x value, delta x2, plus, and then, you know, we're going to keep doing this until we get to the one right before the last one, okay? So plus dot, 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 we're going to keep going. And then the left rectangle guy is going to stop at f of x sub n minus 1 delta x sub n minus 1. Okay, so this is for the left rectangle part. And to emphasize that, yeah, I guess what I'll do is I will just kind of just stay with me, okay? I don't want to make it too jumbled. This is the left rectangle part. Now let's think about the right rectangle part. Okay, so plus, and now the right rectangle, it does not start here, right? It doesn't include, it starts here. Okay, so we're going to get plus f at x2 delta x2 plus f at x3 delta x3. Now, does the right rectangle contain x sub n minus 1? Yes, it absolutely does. Okay, and I am just straight up out of space here. Plus dot 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 f, and the right one's going to stop at n, and I'm going to do it this way just because I'm running out of space. It's going to stop it at n, okay, which means it has n minus 1 in there. Okay, so here's the point. Here's the point. Let me get to the point. First, let me divide everything by 2 because it's part of the definition. Okay, divide everything by 2. Here's the point, okay? F of x sub 1, delta x sub 1, this is unique to the left rectangle approximation method, okay? It's unique to this, okay? Now, all the middle terms, okay, repeat themselves because look, fx2 delta x2 is part of the left rectangle, but that's also where the right rectangle starts. So if you look here, we actually have 2 copies of f of x2 delta x2, and the same is the case for f of x3 delta x3. We have 2 copies of that. We're going to have 2 copies of everything until we get to the very last one, okay? Because the very last one is unique to the right rectangle approximation method. Okay? This guy is RRAM unique. Okay? But the rest of them have 2 copies in the middle. 2 copies in the middle. Okay? So we got one left rectangle unique term, one right rectangle unique term, and then we have 2 copies of everything else in the middle. Okay? And so using this, we can write down our trapezoid approximation method formula. All right, and so this is going to be, I'm just going to try to write it down without taking up the whole screen. We're going to start at x sub 1, delta x sub 1, plus, and now all the middle terms are going to be multiplied by 2. So 2 f of x2 delta x2 plus 2, plus dot dot dot, and then plus 2f, and then the 2 stops at n minus 1. And then we have plus f at x sub n, delta x sub n. Okay, and then we divide all that by 2. Okay? All right, so now the very last thing in this video is going to be plugging in the values from the table into the trapezoid approximation formula. Okay, so yeah, so here's what I'm going to do for that. I don't want to waste a bunch of time. I'm going to summarize the results up here. So for right RAM, we got 130. For left, we got 199. For the trapezoid, when we calculated it the easy way, we get 329 divided by 2. All right. Okay, so there's those results summarized there. And now I need space. So I'm going to erase. Okay, there we go. That's erased. So now let us plug in our stuff. All right, so here we go. Trapezoid approximation method. Boom, here we go. So it's going to be 0 multiplied by this width. Okay. Plus, and now all the middle terms get a 2. So 2 times y value, this one, and then let me think here. Delta x sub 1 is here. Delta x sub 2 is going to be here. So negative 2 to 0, it's going to be a 2. Plus, and then again, it's a middle term. So we get a multiplication by 2. Y value is going to be 10. And then let's think here. Delta x sub 1, delta x sub 2, delta x sub 3. That is going to be 1. Plus, okay. It's a middle term, so it's going to get a 2. Y value is going to be 15. And then the width is going to be from 1 to 4. 3 plus middle term gets a 2. Okay. Y value is 11. And then 4 to 9, width is going to be 5. Plus, middle term gets a 2. 9 times 1. Plus, middle term gets a 2. Okay, times 7. And then 10 to 20, that's going to be a 10. And then let's see, finally, end term does not get a 2. 0 times 10. Okay, so there's that. And then we are going to divide all of that by 2. Okay. So I guess we'll just see what we get, yeah? So let's see, 2 times 5 times 2, that's like 20, plus 20, plus 15 times 3, that's going to be 45. 45 times 2 is going to be 90, plus 55 times 2, 110, plus 18, plus 140, right? 7 times 10 is 70, 70 times 2 is 140. All right. And then all that divided by 2, and now let's see, what do we get? Right. 140 plus 110 is going to be 250. 250 plus 90 is going to be 340. So I made a mistake someplace. Darn. Okay. I made a mistake someplace. That's not good. Okay. Well, maybe one of you can tell me where I made a mistake. Sorry about that, guys. Everything else should be good. Oops.